and welcome to today's SANS webcast. What you need to know about the critical Citrix Gateway Netscaler vulnerability. My name is Carol Auth of SANS, and I will be moderating today's webcast. Today's featured speaker is Dr. Johannes Ulrich, Dean of Research at the SANS Technology Institute. If during the webcast you have any questions for Johannes, please enter them into the questions window. Please note that this webcast is being recorded and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Johannes.
Thank you very much for the introduction, Carol. My name is Johannes Ulrich, and Jason can't join us today, but he helped prepare these slides. In particular, he sort of brought in some of his experience that he had actually dealing with this vulnerability. The company is working for, they have a number of these devices protecting a couple of hundred different websites. So he basically advised me a little bit also on what challenges he ran into applying some of the patches or workarounds that Citrix came up with here. So first of all, what is really the big problem here? The vulnerability has been described as a directory traversal vulnerability, and I'll get into this a little bit later. It's actually not just directory traversal, but what it really comes down to is that without any authentication, an attacker that has access to the Citrix console essentially will be able to execute arbitrary commands without authentication. So that makes that really a critical vulnerability. Positive Technologies, the company that found this particular vulnerability, rates it as a CVSS score of 10. Now, they didn't really justify that beyond saying, well, it's code execution and it's not that difficult to exploit. But we'll have to see. Citrix didn't really sort of note a CVSS number on this particular vulnerability, and Citrix usually doesn't do that. Now, there is at this point no public exploit. However, and again, I'll talk a bit about this, it's not really that difficult to come up with the vulnerability and with at least sort of a partial exploit of some of the issues that are covered here. Now, first of all, who's affected? So Citrix ADC and Gateway are affected, version 11 or version 10 and up. You may also notice that Netscaler, Citrix bought Netscaler way back, I think it was 2005, but the Netscaler name sort of has stuck around. So Netscaler, Citrix Netscaler, Citrix ADC, Citrix Gateway, all of these products are affected in pretty much all current versions of it. Positive Technologies mentioned that the vulnerability goes back 5 years. So that pretty much covers all of these versions. Now, Citrix came up with a suggested fix here. It's not a patch. Really, all it does, it blocks certain URLs from being accessed. Most notably, URLs that contain /VPNs/. This essentially sort of covers part of the admin functionality of Citrix. And then it also has this ... part here that is being covered. But actually, the ... part, according to this rule, only really matters if the user is connected to the VPN. If the user is not connected to the VPN, then Citrix's rule only looks for that string VPNs, so not for that actual sort of directory traversal part. Here's the rule, just highlight a couple of the issues here. So first of all, it returns a 403 forbidden here if the rule triggers. And then when you're reading the rule here, it first looks for the HTTP request URL. It decodes it using text mode. By default, this would decode it using URL decoding. So that may be a little bit of a hint here what's going on. But either way, VPNs is the string it's looking for. And then if the user is not connected to the VPN. That's here what this not client SLVPN is SLVPN sort of is about. Or if the URL again contains the // this directory traversal pattern. So it's either not connected to the VPN, or if the user is connected to the VPN, then the ... matters. So this is really where this comes into. So really the ... only matters if the user is connected to the VPN. Now, whenever you block URLs like this, you have to be a little bit worried about what kind of valid patterns would I block here? VPNs, like I said, it is part of legitimate URLs within the Citrix gateway. Most notably, there are two plugins, one, and that's the one I listed here for Windows, another one for Mac that you can download via URLs that are contain as VPNs pattern. However, most people that use Citrix actually don't download these plugins from their own Citrix install, because you typically end up with an out-of-date version. So a little bit of problem with how the system is sort of set up. You can download these plugins from Citrix directly, and then you don't really have issues with out-of-date plugins. You get the latest, greatest one if you download them. So, okay, not really a big issue. The other problem that you may have is, well, you may use Citrix in front of various applications. That's really sort of the SSL VPN capability in Citrix Gateway, as I call it here, is really sort of more used to expose sort of internal applications. And if any of these applications contain this VPNs URL, then you also may be blocking them. And that's really the trickier part here, because that may be difficult for you to enumerate if any of your applications use this particular pattern. The other question, of course, and I think it's a little bit too early to answer that, is, can this pattern be bypassed? Don't know enough about the vulnerability yet to really figure that out. But you could maybe play with some URL encoding here and things like that to see if it can be bypassed. You can still get to that VPNs URL without actually triggering this rule. And that pretty much depends also on what kind of application you have again in the background, and how this text decode, that's a part of the rule here, essentially normalizes some of these URLs. Now, the other question, of course, is how much do you gain here from security through obscurity? These are not typically systems that are widely advertised to the public, but yes, attackers can certainly still find these systems. And just a couple hints here, of course, Shodan and similar systems, Google, of course, can be used. And just this week, I did a quick experiment to make my honeypots more sort of appealing. I added some TLS certificates to them with names like vpn.citrix. As part of the host name. And after I published after I created these certificates, I got them from Let's Encrypt. Of course, there will be published the certificate transparency logs. And well, it's commonly known really that people are watching these certificate transparency logs and will hit URLs or hosts as soon as they show up here. Now, other things an attacker could do, and I've seen a couple of these things happening already, where they're sort of looking for like JavaScript files and such that are typically part of these Citrix UIs. So that way, I think they're trying to also build some target lists and also eliminate some of the simple honeypots that sort of just put up an HTML lookalike page without sort of really having all these resources. Also a number of cookies that Citrix sets as you're going to the login page, for example. So this again could be used to identify the Citrix service. And this is just my experiment from earlier this week. The green bar here is where I requested the certificate, and you see within a minute, I do see initial hits coming, and these are not the hits. I just want to specify this. When you request certificate, of course, Let's Encrypt will hit the site for the well-known file to make sure that you're authorized to get the certificate. But within 1 minute, I see what I would classify as attacks. Nothing specifically for Citrix yet, but for example, we had here some access for good old WordPress admin pages, and they actually came in via Tor. So I would call this pretty much an attack. And that's about how much time you have after you issue a certificate before the site is being hit. I want to talk a little bit about directory traversal vulnerabilities and what they're all about. Sort of one of those vulnerabilities, it happens. It's often a little bit underestimated because usually it's sort of linked to information leakage, where I could download a file that I'm not supposed to download. Now, here I have a little sort of textbook example URL here, where we try to download Etsy password. This would be sort of the classic exploit here. And for example, in our defending web applications class, we go over this vulnerability. It's typically an input validation flaw, but then it's also what the attacker can do with it once the flaw exists. Very much depends on what permission the web server has on the file system. And this is where things can get quickly more interesting, where, for example, typically I'm able now to download source code because the web server needs to be able to read source code. And of course, if I'm able to write a file and I have a directory traversal vulnerability, then I'm able to overwrite configuration files, maybe upload executables, maybe upload code like PHP code or such to the web server, and with that leverage this directory traversal vulnerability to full remote code execution. Just to give you a sort of a real world example from a security device, one thing I really want to stress here is that this is more of a problem than just a Citrix problem. This year, we had a number of sort of high profile critical vulnerabilities in similar security devices. And here is a FortiGate, another SL VPN. Now, the FortiGate is quite different, but the vulnerability, here's again a directory traversal vulnerability that actually can be leveraged to gain access as an administrator. So first of all, here the blue part, what is the vulnerability all about? So here we are creating a file name, and part of the file name is user provided. That's the language part here, and the %s. Now you may think, okay, I can only get to files here in the language directory, and they have to end in .json. Now, of course, if I add a // here, I can definitely break out of the language directory. But I would still be stuck with that .json extension. Well, that's sort of where the first part here comes in. To kind of prevent buffer overflows, they limit the length of this string to 64 characters here in hexadecimal level 40. So after the user data is inserted, then the string is truncated to 64 characters. So as long as I make this %s long enough that the .json is beyond the first 64 characters, well, the .json no longer matters. And below here, you have an example exploit for this vulnerability. You see here, there's 4 dots needed to sort of get out of the directory. Then you have these additional slashes just to fill in enough characters. And then the attacker here is going after the slvpn_web session file, which essentially is your session token. So now the attacker could download like the administrator session ID and impersonate the administrator, which then of course gives the attacker full access to the system. So pretty straightforward exploit here. And that's really one of the problems with these directory traversal vulnerabilities, that they tend to be not too difficult to exploit. Now, I took a look at Netscaler the last couple of days and to see what I could find about the vulnerability. Essentially, the backend software is pretty much Perl and PHP. It's sort of a mix of the two. The file upload actually part was pretty trivial, I have to say. That sort of took maybe a couple hours to figure out, and it took longer because I ran Netscaler in a VM which kept hanging. So not Netscaler's fault. This was my fault of not setting it up correctly. But overall, not that difficult to find out how you can upload files to pretty much any location that the web server has a write access for. Now, the tricky part is, of course, where does the web server have write access to? And that's sort of where it gets pretty bad, really. There are several directories that are full writable by the web server, even owned by the web server. And these are actually directories that contain scripts that can be executed. So CGI bin style files, PHP directories. Uploading the file is pretty easy. There's a lot of missing input validation going on. And in actually one case, I saw the input validation was commented out. It almost looked like some developer commented out for some testing or so. Maybe something wasn't working quite right. The input validation was too tight, and then that code was pushed live, maybe more meant as an experiment or as for debugging the code. So exploitation is not terribly difficult here. And just to give you a little impression, I don't want to give away the full details here, and I'll talk a bit about this sort of towards the end. But sort of here are a couple scenarios how this could be exploited. We have on the left here our attacker. The attacker would hit a URL that's vulnerable. And again, these directory traversal patterns, they don't necessarily show up in the URL. They may show up in parameters being passed to the script. And I just call them here parameter 1, parameter 2. One would be the file name that I would like to write, and one would be the content I would like to write to the file. If I'm lucky, I would be able to write, like in this example, a PHP file, and then just by hitting the PHP file, I would be able to execute the code here. So this would be sort of the simplest way to exploit this. It's not always quite that simple. Another example, and this may point to the fact that they sort of have slightly different rules for whether or not the user is connected to the VPN or not, is where the attacker drops the file, but the attacker, because they drop it into a directory, for example, that requires authentication, is not able to execute the file. So now they have to wait for a user that's logged in to download, to access the file, and that would then actually trigger the exploit or run the code that the attacker uploaded. There are many examples like this. Also, for example, some that have this happen where it can upload a file into some other directory, let's say temp directory. And in the example of Netscaler, for example, it looks like the current directory is part of path. So an administrator connects by SSH to Netscaler, does an ls in the temp directory. I uploaded a file called ls. Well, that again would trigger it. As a variation of this, the attacker may sort of entice the victim here to actually load the file by, for example, sending an email with an image tag or something like that. So that would be another example in how this type of vulnerability could be exploited. So what can you do to fix this? So first thing you should do, and you really should do this week, is apply the Citrix mitigation. Read the knowledge base article they published. It goes in details over how to apply it. In the blog post I published, they also have some of the logs that you may see if it's being triggered. Now, if you have any additional security devices like next generation firewalls or IPSs and things like this, then please only look for the /VPNs/ pattern. Like I mentioned, the // pattern will not be visible in the URL of the initial exploit. What the attacker can do once they got a hold of your Citrix gateway is they can, of course, then use that gateway to attack your internal network. So any kind of odd traffic that you see from these devices to your internal network, that would certainly be something that you should look out for. And yes, for the initial exploit, authentication is not required. The attacker doesn't really have to hit a login page as such, so you wouldn't really see that. Like I said, there is no real patch yet. There is this workaround. And I believe Citrix sort of did that on purpose. By publishing this workaround or this policy to block these URLs, they basically gave you a tool to block exploitation without giving too much detail about how the vulnerability actually works. And I think that's sort of the balance they tried to strike here, but they wanted to give you protection without giving the attackers a heads up on how to exploit this vulnerability. What I found is that once you see the patch, you'll probably, within minutes, see how to exploit this vulnerability in particular. I'm also guessing here the way I would patch this particular vulnerability. Now, let me see, we have a little bit of time here. So I want to show a quick demo of sort of how this all works. And let me just exit PowerPoint here and share my screen. So, and yeah, I already see a couple questions coming in. So please, if you have any questions, use the question feature here within Zoom. And actually, it's first time we use this platform. So any platform, any feedback on the platform or so, send it to me offline. But would be interesting to hear. So like I said, I don't want to give away too many details. So I just have it sort of wrapped in a shell script here. But it's really two curl commands that you have in here. So I run it here. First one uploads a file with a random file name. The second one just checks if the files exists. And let me just connect to the system here. So at first, with you get sort of this prompt with shell. You get your normal bash prompt back. It's running FreeBSD here under the hood. And let me just change the directory where I uploaded the files. And you see here is the file uploaded. One thing here, yes, it adds this .xml extension. So that's sort of one thing that makes the actual then remote code execution a bit more difficult. But once you know the parameters, once you look at the directory structures here, I don't think it'll take more than a couple of days for someone who knows how to write exploits, maybe a couple hours if you're a little more familiar with this particular system, to actually come up with a workable remote code execution vulnerability for this. It may require a logged in user to actually trigger the code execution, but that's just speculation at this point. So really straightforward to exploit this.